So we're going to talk about trigonometric identities. The first one we have is the reciprocal identities. Kind of already talked about these identities, but just to get them down, the cosecant of theta is equal to 1 over the sine of theta, first one. The secant of theta is 1 over the cosine of theta, second one. And the last one, the cotangent of theta, is 1 over the tangent of theta. Okay, those are my reciprocal identities. Other important identity, we've got the quotient identities. Okay, quotient identities, what are those? That's tangent theta equals the sine of theta divided by the cosine of theta. Once again, we've used this several times, y over x. And then secondly, the cotangent of theta is the reciprocal, so it's the cosine of theta over the sine of theta. Okay. Another important identity here, the Pythagorean identities. Okay, so let's work with a unit circle. X squared plus y squared equals 1. This is the unit circle. Well, what do we know? For a unit circle, the cosine of theta is equal to x, right? It's x over 1, which is just x. And then the sine of theta is equal to y. Y over 1, that's just y. So if I square x, I get cosine squared. And I square y, I get sine squared. Okay, so cosine squared plus sine squared equals 1. This is the Pythagorean identity. Okay, Pythagorean. Identities. Okay, so if I want to get the other two, all I need to do is take the Pythagorean identity. Let me try this again. Okay, duplicate. So what I'm going to do, I'm going to divide everything through by cosine. And what does this get me? Cosine divided by cosine is 1 plus sine squared divided by cosine squared. This is tangent squared theta. It's tangent theta times tangent theta, right? Okay, so it would be like sine theta times sine theta over cosine theta times cosine theta. And so that's tangent and that's tangent, so that's where that tangent squared comes from. Okay. And then I have 1 over cosine squared, which is secant squared theta. So here's another one here. And then there's one more. How do we get the last one? We're going to take the equation, and instead of dividing through by cosine, let's divide through by sine squared. Okay, sine squared. What do I get? I get, well, cosine divided by sine, that's cotangent squared theta. Sine divided by sine, this is 1, equals 1 over sine, which is cosecant squared theta. So my three trig identities that are Pythagorean identities summarized here in this little box. Okay? Those are critical. Okay? You're going to use those so much. And then in Cal 1 and Cal 2, it just pops up over and over and over. So these identities, they are very important. You need to know all of these identities. I cannot stress how important these are. Fundamental. Okay, they're fundamental. They're fun, right? Oh man, this guy's so lame, right? Okay. Some that aren't as crucial, but still they pop up, especially in this pre-calculus class. Okay, they're taking advantage of the even and odd properties of functions. Okay, so we will learn when we start graphing about even versus odd, which trig functions are even, which ones are odd. So here I have the sine of negative theta is equal to negative sine of theta. Okay. I have the cosecant of negative theta equal to the negative cosecant of theta. I have the tangent of negative theta equals to the negative tangent of theta. And I have the cotangent of negative theta equals the negative cotangent of theta. Okay? And all of these are all odd. Okay, those are all odd. Now there's two more. The cosine of negative theta is equal to the cosine of theta, and the secant of negative theta is equal to the secant of theta. These are even functions. Okay, those are even. Okay, so that means if you have, say you had like cosine of negative pi, this is the same as the cosine of pi, which if you go around the unit circle, like if I travel around pi units, then the cosine here, that's negative 1, okay? All right, guys, if you think about it, traveling in the negative distance this way, going clockwise instead of counterclockwise, it's still going to make you end up in the same spot as traveling in the positive counterclockwise for the cosine function and the secant, because those are even functions there. All right, so I'm going to do a video over how to evaluate using these identities, so be looking for that.